Hi, I'm Bill Vales here, and I'm at the Littleton Middle School Science Fair. This is my second year being here, and it's, as you can see, it's really a festive event, and we're going to take a walk around and interview some of the kids with their projects and see what's here. So come on with me and let's see what we find. Hi, I'm here with Dr. Kelly Clenchy, and you're the superintendent of the Littleton schools.
That's correct. Yes.
Yeah. Well, what do you think of this event?
You know, it's a wonderful opportunity for our students to show their potential in terms of scientific inquiry and be involved in project-based learning. You know, nothing is better than having a student research a topic, pose a hypothesis,
Absolutely.
and do the research, and then to set up and have to teach people what they've learned is learning that lasts for a long, long time. So
Yes.
this is a skill that all of our students need to be successful as they continue on their educational journey.
Yeah.
And as a result of this, it's just a wonderful opportunity, great training prior to them entering high school as well.
Yeah.
We are really moving more towards opportunities for our students to engage themselves in project-based learning, and this is a great prelude as to what's going to come during their high school career.
Yeah, I've found that this is my second year doing this, and I've really been impressed with the rigor that the students apply to the projects, the support they get from the teachers, and I'm sure their parents in some of these projects that they undertake. And I'm also very impressed how closely they follow the scientific method, which is really important.
It is. That's something that our students really need to understand and be able to use.
Yes.
And to see it in a fashion where it's being actualized. We talk about scientific method back in elementary school, but they really have an opportunity in middle school to demonstrate their skill sets and take risks by looking into areas of interest that go beyond the curriculum. So it's a great opportunity.
How important do you think these sorts of projects and STEM education is in general for the students?
Well, I think it's important, and it goes far beyond STEM. Whatever our students are going to do in later life, they're going to have to be able to apply higher learning concepts, problem solve, work within a group, teams, and be innovative and entrepreneurial. And this is just an opportunity for our students to start working on those skill sets, and as they go through our high school, they'll have many more opportunities to continue working on those skills.
Yeah. And also part of this is their ability to communicate their results, and communication plays such a key role in all disciplines.
It does. You know, we can call them alternate skills, soft skills, but as a district we really believe in developing the whole child, and our curriculi focuses on communication skills. It doesn't matter what subject they take, there's an opportunity for our students to develop those skills. And as a superintendent, I really notice the difference when our students are doing presentations, whether it be in the classroom or at a school committee meeting. With LCTV, we've had a chance to film some of the presentations, and I'm really impressed with our students' presentation skills. They're confident,
so was I.
Well organized, and you know, they're really developing this as a craft. It's an essential craft.
Yeah,
so.
Absolutely. Well, I want to thank you for taking a few minutes to talk to us. We have a lot of projects we have to look at.
Yeah, that's great.
So thank you very much.
Thank you for coming out tonight.
Thank you.
Appreciate it.
Hi, I'm here with Virginia Shea, and you have a very interesting looking project. So why don't you explain to us what you have?
Well, I have an engineering project, and it was to build an electrostatic precipitator, also known as an electrostatic particle collector. But before I get into the idea of what an electrostatic precipitator is and how it works, I need to get us back to the basic principles of science. So
Okay.
Right here we have a balloon, and we all know what happens when you rub the balloon against it.
Yep.
Well, your hair is attracted to it. And why is that? Well, what happens is, originally, both the balloon and I, we have an equal amount of protons and electrons. And protons are positively charged particles, and electrons are negatively charged particles. So what happens is when I rub this against my head, I am transferring electrons, some of my electrons, to the balloon. So now the balloon has more of a negative charge.
Okay.
And I now have more of a positive charge because I have more protons.
You've
then-
lost some electrons.
Yeah.
Right.
So, as everyone knows, opposites attract. So when I go like this and now that's negatively charged and I'm positively charged, well, I'm attracted to it.
Yeah.
And that's pretty much the basic principles of how an electrostatic precipitator works.
Okay.
An electrostatic precipitator is a device that collects small particles using an electrostatic field. And an electrostatic field is a field that is created by two opposite charges, so positive and negative, that come together, and in between an electrostatic field is created. So, I'm going to show you how to go. So, for my testing, I use this as my smog source.
Okay, and what's that make? What
This
is?
is an inset.
A what?
This is an inset.
Okay.
So what I did is I lit it and then I blew it out and now I have smoke.
Okay.
So I put it under here and it goes to the top. Nothing's happening.
Okay.
And it so when I connect these alligator clips to here, to this Wimshurst generator, and I start turning the Wimshurst generator, all of a sudden I create an electrostatic field right here.
Okay.
Well, why is that? So, as I said, an electrostatic field is created by a positive and negative charge coming together. So what happens is when the Wimshurst generator is on, this container turns positive, and this mesh becomes negatively charged. So the smog coming from here, when it goes through the negatively charged mesh, like the balloon, it receives electrons.
I
So
see.
now you have more of a negatively charged smog particle.
I see.
And so, it's floating around here, and then all of a sudden meets up with this material, and it sees positively charged ions. And so what happens is, it's coming up and it's rising, it sees that ion, and it goes like this because it's attracted.
Okay.
And it's stuck there. And then you don't have smog coming through the top, because every time a negatively charged smog particle comes, it is attracted to the positively charged ion.
I see.
And so my engineering goal was to create an electrostatic precipitator using an electrostatic field to reduce the amount of smog in the air. And so I'm not going to get into prototype 1 or 2 because those aren't as important, but because all my data is on prototype 3. But what I did is, originally at first, I only tested the distance of this aluminum foil container to see if by changing the distance, the strength of the electrostatic field, would that change the efficiency of collecting smog. And then I decided that I was gonna, for fun, just test these out and see, if they did well. And this is emery cloth and this is aluminum tape. And I ended up realizing, well, these both are really good at collecting smog particles. So I decided I'm gonna add that into my testing.
I see. Now this has a practical application from reading your board. I mean, the idea here is that you can help clean up the environment by capturing smog.
It's a temporary thing.
Yeah.
Because in the end, we can just do this simply, but until we figure out a way to reduce the amount of fossil fuels and burning of fossil fuels, we're never going to change the environment.
Yes, I know.
So that's
sad, isn't it?
So that's also the idea we have to get at is this is also making a statement that we have to now figure out, we can use this for now, but we have to start figuring out a way to reduce the amount of fossil fuels that we burn.
Yes, yeah. And carbon dioxide is one of our big enemies in that, and methane and, other things. Now, I know when you crank that up from experience, that can generate quite a shock.
I mean, I've had my experience where I've been shocked, but it's more of for me, it's like 2 times the amount of shock you get when you hit a doorknob after rubbing against a rug. But it's more unexpected rather than painful. So that's a good one.
Well, I appreciate you sharing this with the viewing audience. I really appreciate the motivation, what motivated you to do this, and I'd encourage you to keep up with this and other ideas that will benefit our world, our environment. So thank you very much. Thank you. Hi, I'm here with Katie Rank, and I got your name right? I got your name right.
Yes, you did.
What do you have here for a project? Cookies is what brought me in.
Don't burn the cookies. scientific title for this project is A Study of the Effect of the Type of Baking Sheet on the Browning Level of Cookies. So during this project, I basically tested the cookies on different baking pans right here, tin, dark, non-stick, and aluminum, to see how they would burn and affect it. So the research question for this project was, what is the effect of baking sheets on the browning of cookies?
Okay. And your hypothesis?
My hypothesis was, if cookies are baked on non-stick aluminum, tin, and dark sheets, the ones baked on aluminum baking sheets will not burn.
Okay. You must have had a lot of fun with this project.
I did.
Tasting things.
Yeah, they tasted very good at the end.
Yes, yeah. So, tell us about some of the types of cookies you cooked, and if that made a difference, and what your results were.
Yes, of course. I tested a basic sugar cookie batter because I decided if I were to test, say, chocolate chip, the chocolate chips inside the cookies, they would burn down, and that would, while they're burning down, they heat up, so that would maybe affect the differences. So I just stuck with a classic sugar cookie recipe. And my results were that the tin pan did not burn it at all. It did barely, but the average was 3, so it was that very light color.
Oh, I see. Yep.
Yeah, but in the end, I learned that all baking sheets could eventually cook the cookies to the same amount. It would just take different lengths of time.
Yeah. Great. How many cookies did you eat going through this process?
A lot.
Did you really?
Definitely.
Yeah. This is great.
Thank you.
I see you put together, you have all your raw data here.
Yeah.
Yeah. So, I mean, it's a fun project, but it had a scientific basis.
Yeah.
That's great. Well, wish you best of luck, and thank you very much.
Thank you.
Thank you. Well, I'm here with Alicia Patel, and you caught my eye right away because you were here last year, and you did really what I thought was a very innovative project working with ferrofluids.
Thank you.
And what are you doing this year?
This year I created a bioplastic that dissolves in the ocean. It's made out of simple ingredients and it dissolves when it touches ocean water. This could potentially, we could switch out all petroleum-based plastics and use bioplastic, and it won't harm the ocean, the environment, or humans.
Again, you have a great motivation for why you're doing these projects. So last year, you must have been in 7th grade, correct?
Yep.
Okay, now you're in 8th grade. So you're still motivated to clean up the environment.
Yeah. So last year I did my project because of the BP spill in 2010. This year I researched a little bit more on the oceans, and I found out that plastic pollution was a really big problem, and I wanted to do something to fix it. I love animals, and I wanted to do something for animals, and my project was born.
That's great. Can you quickly run us through your engineering goal, your hypothesis?
Of course. So my engineering goal was to design and create a bioplastic that decomposes when exposed to ocean water. My target user was anyone who uses plastic on a daily basis, such as grocery stores. I used a couple simple ingredients like distilled water, cornstarch, vinegar, and glycerin. I mixed them in a pot and they formed a plastic. They dissolved within 2.5 hours, as you can see here. Yeah.
This is great. I expect to interview you in about 6 or 7 years when you're in college to see where all your work has led you. Because I think you're going to really make a difference in the world.
Thank you.
So keep up the good work.
Thank you.
Great. Hi, I'm here with Shay Regan, and we're at the science fair. How are you, Shay?
Good, how are you?
I'm good, thank you. What do you have for a project?
So, I wanted to test whether organic soil mixtures would be better than the regular potting soil. Because I found that in certain places where they can't afford the expensive fertilizers, I was trying to find ones that would be easier.
I see. Well, that's very interesting how you went about that. So you went about it from the standpoint of people didn't have a lot of resources to purchase things. So that's very good. So what's your hypothesis?
So, I planted magmono, tea leaves, coffee grinds, and then regular potting soil. So, my hypothesis was that organic
Okay. I'm going to take a guess here. Are these marigolds?
Yes.
Okay. Okay. So, what were the results?
So, right at the beginning, the back corner seeds, the back corner plants were growing better. So, at the end, the back corner grew the most, then coffee grinds grew the second, and then it was the potting soil, then the teas.
I see. And did you have to be sure that you were using the same amount of water, applying the same amount of water for each?
Yes, every few days I watered the plants.
Yeah. Great. Great. How long did it take you to put your project together?
So I started at the beginning of January. I planted them, and then over 4 weeks I recorded the data.
Great. Great. This is great. You have a beautiful display. Do a good job explaining it. And I wish you a lot of luck. You keep up the work.
Thank you.
Thank you. Okay, I'm here with Patrick Berry. How are you?
Good.
Good. What do you got?
So I did which brand of duct tape is the strongest.
Okay, duct tape. My granddaughter loves duct tape.
So my hypothesis was that Gorilla is going to be the strongest
Okay.
because it's the thickest out of all of them
Okay.
and it has the most adhesive.
Okay.
But it turns out that 3M is the strongest. So for my average graph of the weight, my 3M hold it 27 pounds, and this got 15 pounds, and then Duck Brand got 15. So, and if you want to feel how strong, this is how much 27 pounds feel like
Okay.
of how much this holds.
Okay. And when you say that held that, does that mean that it broke when you had more weight than
Yeah.
that?
So it either broke here or the adhesive wore off
I see.
every 5 pounds that I added.
I see. So if it broke here, does that say something about the adhesive?
I'm not really sure.
Okay. But you did find that some things broke here and some things broke in
Yeah,
the
the
center.
adhesive worn off and then it just like snapped off of it.
I see.
Or the tape like officially broke.
I see. I see. Well, very interesting. So which tape should I buy?
Just by 3M.
3M.
It'd be all of them by 9 pounds.
Okay. So you should get together and write a resume to 3M to hire you. Okay? Thank you very much, Patrick. I'm here with Will Allen. And Will, tell us about your project.
My project is expectation.
Okay.
My research question is, how does padding in a helmet help the force of impact?
Now, when you say help the force of impact, do you mean protect you against the force of impact?
Your head.
Okay, it protects you. Okay.
My hypothesis is the more padding there is in the helmet, the less the egg will crack.
Okay.
And my hypothesis was, it was supported in my data.
So how did you go about testing?
I had a helmet, and then for the control group, I put no extra padding, and I just put it in a Ziploc bag. And then for the other ones, I put different types of padding right here. And
So what type of helmet did you use?
a Riddle football.
Okay, okay, like this. Okay. Okay. And you put the egg in the bag?
And then I duct taped it to the bottom, like
I see. And then you just dropped it?
from like above my head.
Okay. And what did you find when you dropped it?
I found that in my data analysis, the egg with no padding cracked on average 80% more than the egg with padding. Extra padding.
80%? Wow. How many dozen eggs did you go through?
A whole padding.
Yeah, a whole dozen eggs? Yeah. Did any of the egg leak out of the bag?
No.
Okay, that was good. Okay, did you have fun doing this?
Yeah, it was a good experience.
Yeah, good. Well, this is great. And I suppose the idea behind something like this is to be able to improve helmets to protect people that are using them. So, okay, thank you very much. Hello, ladies. Hello. I interviewed you before the fair, and you have the perfect flip. And which one of you was the flip expert? Go ahead. Do that again. Yeah.
One more time. One more time.
Okay. Can you explain for us what's going on here and what you're testing?
Yeah, so there's three main objectives that are happening. Force, angular momentum, and gravity. So the force, when it's flipped, affects how it will land. The angular momentum is the water pulling it down to the ground. And the gravity pulls the water bottle.
Yeah. I'm not leaving until I get it.
Try flipping a little harder. A little less. Yeah.
Thank you, ladies. I get it, though. I get it.
Yeah.
I'm here with Catherine Hohenschel. How are you, Catherine?
Good, how are you?
I'm good. What grade you in?
8th grade.
8th grade. So Miss Finity is your teacher.
Yes.
What's your project?
So it is called a flying snow shifter, and what I did is I built an airplane that switches from wheels to skis in its landing gear. So if people have to land in the wintertime, then and the runway's not safe, then they could switch. It could be an emergency switch to skis.
Very interesting. So, what's your engineering goal? Take us through that. Did you have a hypothesis?
So I didn't have an hypothesis because this is an engineering project.
Yes.
But I have design criteria. So my engineering goal for this project is to create landing gear for airplanes that switch from wheels to skis. During the winter time, landing is very difficult to predict. Like there's delays all the time, and I thought maybe there's a way to help reduce that or make it safer when you have to land in the winter. So I was thinking that maybe having wheels that switch to skis could make landing much safer.
I see. Now, is the idea to have it switch from wheels to skis?
Yes, I can show you. So
Okay.
right here. So we have wheels up top, right? Or wheels getting ready to land, right?
Yeah.
And then the skis would be up top. So what happened was, how I built this is I put fishing line through here.
Yeah, yeah.
This is just a prototype, but
Sure.
And then what happened is, since it's twisted around, you would pull the emergency switch in here, and it unravels it to make it go to skis.
I see. So, would that switching occur after the plane is land or before the plane lands, or?
I'm thinking it would be emergency landing if they had to emergency landing because of a storm or something, like
I
they had
see.
to land because it's an emergency. So that would be an emergency switch. So
I see.
put it right in the airplane.
I see.
So yeah.
I see. What a great idea.
Yeah.
What a great idea.
It was very fun making it.
Was it?
Yes, I
Yeah.
did like building an airplane. It was
Yeah,
fun.
good for you. Well, this is great. I see you have all your data collected.
Mm-hmm.
Yeah. Very good. Well, I wish you a lot of luck.
All right, thank you very much.
And I'm going to look for this idea on some of our new jets.
Okay.
Okay, thank you.
Thank you.
Hi, I'm here with Vivian Lance. How are you, Vivian?
I'm very good, thank you.
Good. What grade are you in?
I'm in 7th grade.
7th grade. What's your project?
My project is corandrum sativum, an effective biosorbent.
Okay. Now, for the lay person, what is coriandrum sativum?
So corandrum sativum is the scientific name for cilantro.
Cilantro. It's great with salsa.
Yeah.
Yeah. Okay. So what were you trying to do?
So I was thinking about developing kind
be the best one to do that.
Okay, so biosorbents, are those a class of materials or plants?
It's mostly herbs. So like there's also parsley can be one too.
Okay.
It's mostly herbs from what I've researched.
Okay.
And they're a great substitute for getting water filters.
Interesting. Okay, so what was your research question?
My research question was, is Corandrum sativum cilantro an effective biosorbent that will take out most pollutants in 12 minutes?
12 minutes, okay. And your hypothesis?
My hypothesis was that the Corandrum sativum will clean out pollutants such as lead from water, and it'll work best in 12 minutes because I thought that the longer something's in the water, the more it could take out.
I see. Boy, pulling lead out of the water, that's a very noble project to take. Yeah, because lead can be very damaging.
Yeah, so lead can damage children's brains, their nerves, and so what happens for lead poisoning is it's irreversible.
Yes.
And it's very sad because like these people they don't have anything to clean their water, and so then they're getting lead poisoning that they probably can't fix.
Yeah. So what materials do you have?
So I got my polluted water from a worker at the Littleton Water Department, and he gave this to me for free. It has 25 parts per billion, that's ppb,
Parts per billion.
and lead in it.
Okay. Both heavy metals. Okay.
And so the lead was over the safe limit, which is 15 ppb. So
Okay.
when I was handling it, I used gloves in case the water would splash up. It might irritate or burn my skins, and so I took a precaution.
I see. Okay, so you had some contaminated water, and did you set up your filtering system?
So I made a cilantro tea bag because that's how you administer it in the water.
Okay.
So I had 9 samples of polluted water, and I made 9 tea bags with 1 teaspoon of cilantro in there
Okay.
to put in the water.
Okay, and you put it in for 12 minutes?
Well, I did it for 3 different times because I sort of wanted to see if 12 minutes. So I did 3 minutes, 6 minutes, and 12 minutes.
Okay. And what were your results?
Well, I found that for 3 minutes, it went from 25 parts per billion of lead to 16, which was exciting because it did prove that it was an effective biosorbent.
Right.
And then for 6 minutes, it went from 25 to 14, and I thought that was even better because it's taking out more, and it's under the safe limits. And then for 12 minutes, it stayed the same. So it went from 25 to 14 again, showing me that after 6 minutes, the cilantro cannot absorb any more pollutants.
I see. So that implies the material has become saturated. I see. What do you have here?
So I had to bring my water samples. Well, I had to choose 3 because these water test strips I had were faulty, and I tried them 20 times, maybe like 20 of them, and they did not show any results that gave me any answer. So I reached out to the worker at the Littleton Water Department, and he told me to go to the Neshoba Analytical. So I went there, but for 3 tests, it was $120.
Oh boy.
So I had to rule out copper because my mom and my parents, we decided that I can't do all of them.
Yeah.
That's a little unreasonable for a science pod.
Yeah.
So I chose 3 samples to be tested, 1 from each interval of time, 3, 6, and 12 minutes.
Okay.
And then the results came back to me. They gave it to me in an email, and they sent me a letter, so I have a copy of it.
Okay. And that supports your hypothesis.
Well, it supports my hypothesis in the fact that cilantro was an effective biosorbent, but the cilantro stopped working after 6 minutes, and I thought it would work best in 12 minutes.
I see.
So it disproves my hypothesis.
I see. Very very interesting. Well, this is really well put together, and your idea is very good.
Thank you.
And I'd encourage you to continue thinking of ways that we can clean up our environment. I think that's very important. And as you found out, lead is very damaging.
Yeah, it's a very bad pollutant.
And you also found out, as in real life, there are budgeting limitations.
Yes.
I mean, that was part of the lesson.
Just learn that you can't, you don't have an unlimited source. You just sort of have to pick it and how much you're going to do and sort of go with it.
Yeah. I'm very impressed in your project.
Thank you.
Very nice job. Okay, thank you, Vivian. Hi, I'm here with Josh Poulin.
He's not here.
Okay, Jack Dennehy. That's you? And Brendan Reardon. Okay, what do you have here?
So we did a project on how magnets might be able to be the future of transportation.
Okay.
And so for our first attempt, we used wood and we outlined it with magnets. So basically on each side there was magnets. And then we had the whole bottom of this. This strap right here wasn't on it. We had it aligned with magnets. And then we tried putting it on, but it was too heavy and would have slid.
I see. So is this being levitated by the magnets?
So it's not being held up from the side, as you can see. It's actually levitating.
I see.
You can see under it that there's a gap between it.
Oh, yeah. What kind of magnets are these?
Do you know?
I know these are grade A magnets, but I don't know what kind of magnets they are.
When you say grade A, what does that mean?
So grade 8 magnets.
Grade 8.
I don't know how much the scale goes up to, but those magnets are, so that's like the strength of them. So the higher they are, the more powerful they are.
I see. I see. So what, did you have a hypothesis, or was this an engineering project?
It was in engineering.
Okay. So what were you trying to show?
Our engineering goal is we wanted the car to levitate and move on its own, but we couldn't get it to move on its own. And for the materials, right here, we needed lots of wood. So we needed super glue wood. It takes a lot of materials, and it's a bit expensive. It took like $30 to make this, $20 or $30.
$30.
So, and then for the track, we wanted to use polyolithic graphite, and that repels all kinds of magnets. So South and North Pole magnets are both repelled. And if we had that, that probably would be able to work better. But since it's really expensive, we had to go for our next option.
Okay. Okay. So, would you term your project a success with what you found out?
So, 75% successful. So it couldn't move on its own, which was what we wanted to do. So I guess it was partially a success because we got to levitate and we got in a track and it goes in a straight line with this. But sometimes it goes up to the side. But, and then I call it 75%.
Well, very good. Well, continue on with these ideas. Anything that would make transportation safer, cheaper, is a good idea. So, good job, guys.
Thank you.
Thank you. I'm here with Cheryl Temple, the principal of Littleton Middle School. How are you? I'm very good. This is quite an event. What do you think about it?
It's wonderful. The kids have been working for months to get ready for their presentations for tonight. I'm really impressed at the variety of presentations tonight.
Yes, yes. This is my second year doing this show, and the rigor of the projects and what the kids put into it is really, really very impressive.
Yes, I agree with you. This is the first time I've seen the science fair presentations here, although I've heard over the years about how well the kids have done. And I'm so impressed tonight at how beautiful the presentations are and how well spoken the students are.
They really are. Not only do I find that they follow the scientific method, and you know they do it in an iterative fashion when that's needed, but they really have the ability to communicate clearly, and that's so important in the whole package.
I was talking to the superintendent earlier, and we were talking about how when we were in middle school, we didn't have opportunities to stand up in front of our peers and give a presentation like this.
Yes.
So when we got that opportunity when we were in high school or college, we were really nervous about doing it. And our kids are extremely confident because they've been having these opportunities since they were at the elementary school.
Yeah. So while the STEM areas are very important, it is also important to be able to communicate, you know, and be able to have those other skills for that whole package.
Exactly.
And I would say that you at Littleton Middle School, the teachers, the staff, the kids' parents have really made that mark again. So
everyone really should be commended. This is an excellent turnout tonight.
So thank you very much.
Thank you.
Thank you.
Pleasure.
Bye-bye.